if you see this is the equation that they start off with, and this is the one you want to make it look like, couldn't you just do, because look at the final thing. Final thing doesn't have a fraction. It also doesn't have tan, does it? Wouldn't it be easier if we could get rid of the tan first inside here, and the tan first inside of here? I'm saying, couldn't you replace tan, like just focus on the first step, that would help. It would probably make sense to do this first, wouldn't it? Okay, and then why not do this separately somewhere else first to see what it becomes? Let's go ahead and do that. Plus cos x over cos x, but up top it becomes cos squared, doesn't it? Because you do multiple. Yeah, we took cos x and realized same thing as divided by 1. If we multiply bottom by cos x to make the denominator the same as cos x over here, we must do the same up top, times by cos x. And that's where we get sin x plus cos squared x divided by cos x. So that's where you get the first thing, sin x plus cos squared x divided by cos x. Divide that whole thing by, you can see the same thing that happens over here, doesn't it? Sin x over cos x minus cos x cos squared x equals to k. This can be simplified into what? Sin x minus cos squared x divided by cos x. This thing divided by this thing cancels out the cos, doesn't it? Any confusion why it cancels out? If you're confused, do 2 divided by 3 divided by 3 over 3. You'll see it gives the exact same answer as 2 over 3. Or if you do 2 over 9 divided by 7 over 2, it's just going to be the same thing as 7 over 9. Oh, excuse me. It's divided by 2 over 7. I'll do this again. 2 over 9 divided by 2 over 7 is just going to be, just type that in a calculator. What does it give you? Gives you 7 over 9, doesn't it? See how that works? It just basically cancels out the number up top, doesn't it? Excuse me, the number over here, right? Just like if you do the last one, 3 over 4 divided by 9 over 4. Doesn't that just give you 3 over 9? Whenever you divide two fractions by the same denominator, it just cancels out the denominator, as it directly becomes top thing divided by bottom thing. This is the algebra we were supposed to pick up on. Sin x plus cos squared x divided by sin x minus cos squared x now equals to k. And this is where you do, this is where you realize, because the final thing doesn't have a fraction, we've got this so far. Sin x plus cos squared x divided by sin x minus cos squared x, that's what we have, equals to k. And then it's pretty obvious what you do next. Sin x plus cos squared x equals to k sin x minus k cos squared x. If you get lazy about writing sine and cos all the time, I think you could sort of feel like, you kind of notice it gets a bit tiring, right? The hand gets a bit tired writing sine and cos all so much. You can just write s plus c squared equals to ks minus kc squared. That's allowed. It helps, doesn't it? And it's pretty obvious from now what we would do, because final thing is only sine. You've got cos. S plus 1 minus s squared, isn't it? Because you want to get rid of the cos. You know, cos squared can only become 1 minus sine squared. It perfectly fixes a solution over here to make it look everything like sine. Ks minus k times 1 minus s squared. And without further ado, just do the basic algebra. S plus 1 minus s squared equals to ks minus k plus ks squared. And you move that to the other sides, you get... Or you can move everything else to the other side, can't you? But yeah, you could write it this way. Let's just say you moved everything to the left-hand side. S plus 1 minus s squared equal minus ks plus k minus ks squared equals to 0. The s's belong to the s's. So s squared brackets negative 1 minus k plus the s minus ks, s bracket 1 minus k plus 1 plus k like this, isn't it? Equals to 0. And let's have a look at the only difference we have left now. We pretty much have this identical, except this is k plus 1. This is negative 1 minus k, isn't it? Times sine squared. We've got sine squared times this, but this is minus 1 minus k. K plus 1. It just means they multiply the whole thing by negative 1. So this is what we get. S squared bracket 1 plus k times plus s times k minus 1, because negative 1 plus k becomes k minus 1, plus, it's the minus over here now, so this just becomes the minus, bracket k plus 1 like this, equals to 0. Negative 1 times this whole thing. This means negative times this whole brackets, which means negative 1 times this. You can do negative 1 times that, can't you? There's no rule why I can't do that. Negative 1 can be multiplied by this, because what happens when you multiply negative 1 by this? It becomes negative 1 plus k. Which is the same thing as k minus 1, because negative 1 plus k is the exact same thing as k minus 1. We're trying to prove how this becomes this. If you're wondering why the minus over here applies to this only and not this, think about it this way, okay? If we had to multiply negative 1 by 5 squared times negative 1 minus 2, we could say that's equal to negative 5 squared times negative 1 minus 2. But we can also say 5 squared, we end up with 5 squared times 1 plus 2. Check this out. Negative 1 times 5 squared minus 1 minus 2, what does that become? The rule is that's the same thing as 25 times minus 3, which is negative 75. Negative 75 times minus 1 is 75. Negative 5 squared times this is negative 75, so 75. Is this also 75? Yes. Do you see what I mean? Like, because multiplication, right? There's no rule why you have to make it multiply by this. It's the same thing as multiplying by the second component, because this is the product. And you realize you kind of have to do that, because you've got minus 1 minus k over here. You have to prove it becomes k plus 1. That's another clue. You have to find some way it became k plus 1. So that's where you end up with the final answer. What I recommend over here is once you get to this stage, you can already prove how it becomes this. Just copy that final line down. K plus 1 sine squared. You prove it became that, because you've already got the correct working over here to prove how you arrived at that proof. So you just copy that down, and that's your proof over there. Hence, solve this. This is where common sense tells you, hey, this thing equals to 4 is the same thing as doing that equals to 4, isn't it? See what I mean? Now, what I mean is, like, look at this. This thing equals to k is the exact same thing as this, is my point. If this became this, doesn't that mean this will become 4 plus 1, bracket sine squared x, plus 4 minus 1 sine x, minus 4 plus 1 equals to 0? What do you mean? I'm not too sure about your question, but if you're asking the reason why we can replace k with 4 is because we saw what it was before. The only difference is k is 4 now. Like, by definition, if this can become this, it doesn't mean if this and this is only different by k is equal to 4, doesn't that mean it also becomes this still? It's just k was 4, you replace the k with 4 over there. This is math logic. And you can tell, why do we want to do that? Because, well, this is a fucked up equation. We can solve this instead now, can't we? And also the clue over here, hence, it's kind of implying, right? You definitely use the previous information. I mean, what's the only way you could use from the previous, what's the only information from the previous part? This. Proving that this became this. A messed up looking equation became something much easier to solve. And now once you have this, it's pretty straightforward, because 4 plus 1 is 5, so you write 5 sine squared. 4 minus 1 is, you don't need to be told you can simplify that. Minus 4 plus 1 is just minus 5. Oh, we have a quadratic over here, don't we? Because remember the definition of quadratic? When you see the only two differences over here is one thing and another squared, you can just let something equal to sine x, can't you? U equals to sine x. 5u squared plus 3u minus 5 equals to 0. Calculate that stuff if you want. 5 equals, 3 equals, negative 5 equals. U is equal to. So let's rewrite this. 4, 5 sine squared x plus 3 sine x minus 5 equals to 0. You do not get a big number, you get a number that doesn't look clean. Anyways, you realize u is equal to, you can write out the exact answer, it's right, negative 3 plus square root of 1 over 9 over 10, or u is equal to, this is the best way of writing it. It's the most intuitive, like, common sense way, right? Like this. Which means the same thing as doing sine x equals to this. Do you see why what I'm writing down might look like it's unnecessarily long, but reality is just the most logical way of writing it down? You might end up writing more, but it's very easy to understand what's going on. Because you're saying, right, u is two possible answers in the calculator, which means sine x, which is what you're trying to find over here, because you're trying to find x. And this is pretty straightforward, because you just do shift sign of this answer. Clear your calculator, right, and you just do shift sign of that answer, type that in. Negative 3 plus 1 over 9, 109, divide that by 10, shift sign of that, and that's where you get 48.1 degrees, comma. What's another answer? 180 minus, so you do 180 minus. Do you see what they're testing on over here? And then you do a shift sign of that, and you realize math error, so you just ignore that, and that's your two possible answers. Now, you are at a point where you need to be able to tell, because I'm telling you for pure, you can guarantee every single one of the questions, the answers you write down, you can guarantee whether they're correct or not. How would you tell if this is correct or not? Check this out. You have on your calculator 139.92 right now, yes or no? You've got a full answer there, right? It's recurring. Here's what you do. Remember the definition? Like, the whole point of this is you're trying to find what number goes into tan of that. Tan of what number plus cos of that same number, divided by tan of what number minus cos of that same number is going to equal to 4. The correct answer means if you write down the exact expression, tan of that plus cos of that, divided by tan of that minus cos of that, and press equals, it better equal to 4. It better equal to 4. So now you do fraction. You write tan of answer. So you do type in fraction on your calculator, type in tan of your answer, close the brackets. You should have fraction, tan bracket answer, plus cosine, bracket answer, yes? Know what I'm talking about over here? Divided by the same thing, tan answer. I think you know what we're getting at. Minus cosine answer. Close that. And press equals. And D gets 4. Does your calculator confirm it's 4? Do you see, this is exactly how you can guarantee when you finish the whole paper and you do this kind of check for all these questions, how can you not just know for a fact you're getting an A star? Do you see, like, this is the final stage pretty much of like being prepared for the exams. You can actually literally check if your answers are 100% correct. Because if you really understand algebra, right, it's this equation, no matter what it is, it's just trying to find that mystery number that goes inside there to make it true.